So in today's video, we're going to be looking at 10.1, which is on rational exponents. So we're moving away from geometry now. And as a quick reminder, a rational number is a real number that can be written as a ratio of two numbers. Some examples are 3/4, 1/2, 3, because it can be written as 3/1, and 5/6. But in this lesson, we're not necessarily looking at rational numbers, but rational exponents. So we need to define what a rational exponent is. And the way I've written it is b to the p over q. So that means it's going to be some number, some base, to the power of a rational exponent, so of a fraction. And the definition is that if p and q are integers with q greater than 0, so not equal to 0, again, because anything divided by 0 is undefined, and b is a positive real number, then the base of b to the power of p over q, is the same thing as the qth root, that's what I said there, okay, to the p power, or the qth root of b to the p. Okay, so the order in which you take the root or the whatever power it is of your base is not specific. It's usually dependent on what you think would be the best mode for simplifying the exponential expression. So let's look at some examples. Let's start off by looking at number 2. Okay, we want to simplify 27th to the 1/3. So 1 is my power, right? It's going to be 27 to the 1, and 3 is my root. So I'm going to take the cube root of 27 and then take it all to the 1 power. But that's the same thing as the cube root of 27. So really, I'm just looking at the cube root of 27, which is 3. Let's try one a little more difficult. For 6, it says 27 to the 2/3. So 2 is what I'm going to raise my 27 to, and 3 is what I'm going to take the root of. So this is the same thing as the cube root of 27 quantity squared. We know the cube root of 27 from number 2 is 3, so we're going to evaluate that first. And then all we have to do left is square it. So that's going to be 9. Now let's look at 12. 12, we've got 4/9 to the negative 1.5. Now, we want to deal with fractions. We want to deal with ratios rather than decimals. So we're going to rewrite that power as 4/9 to the negative 3/2. Because 1.5 is the same thing as 3/2. Okay? So this is the same thing as 4/9 to the negative 1/3 and then the square root, right? Because this is my root and this is my power. So this is the same thing as the square root of 4/9 all to the negative 3. So the square root of 4/9 is 2/3 to the negative 3. A negative exponent means I use the reciprocal, so it's 3/2 cubed, which is 27 over 8. Okay. Let's keep looking at some other ones. In 20, we have the expression 8 to the 2/3 minus 8 to the 1/3 quantity cubed. And so what we need to do is we need to evaluate this expression. So first thing I'm going to do is I'm going to rewrite my rational exponents. So I've got the cube root of 8 quantity squared minus the cube root of 8, all of that cubed. Remember, you cannot just distribute the power to each term in that expression. You have to evaluate the inside the parentheses first. Remember your order of operations here. So cube root of 8 is 2. So 2 squared minus 2 cubed. I've got 4 minus 2 cubed, which is 2 cubed. So I've got 8. For 26. 26, we've got the cube root of 8 times b to the 6 times c to the negative 4. Now, because these are all being multiplied together, we can actually break them apart into 3 separate radicals. We've got the cube root of 8 times the cube root of b to the 6th times the cube root of c to the negative 4. And using our knowledge of rational exponents, we're going to simplify that cube root of 8 to 2, and then rewrite our b to the 6 as b to the 6 over 3, and our c to the negative 4, the cube root of that, to c to the negative 4/3. Now that it's in a, since the power of b here is 6/3, that can be reduced to 2, right? So I actually have 2b squared times c to the negative 4/3. Okay, now we're going to look at 32. 32, they give us the 5th root of 27 cubed over the 5th root of 9 squared. So first thing I'm going to do is I'm going to rewrite these as rational exponents. So I've got, on the numerator, this is 27 to the 3/5 over 9 to the 2/5. I want to bring up that 9 to the 2/5, so it's actually going to be 27 to the 3/5 times 9 to the negative 2/5. And then we can add the exponents if we get the same base. So I'm going to change 27 to a base of 3 cubed to the 3/5 times 3 squared to the negative 2/5. So when we have a power to another power, we multiply the powers, right? So 3 times 3/5 is 9/5. And 2 times negative 2/5 is negative 4/5. Then I'm going to add the exponents. So I've got 3, 9 over 5 minus 4 over 5, which is 3 to the 5 over 5, which is 3. Okay, now let's look at 34. 34, we've got the 6th root of 8 cubed over the 6th root of 4 squared. So I'm going to rewrite each of these as rational exponents. 8 to the 3/6 over 4 to the 2/6. Just like with the previous example, we're going to bring up that 4 from the denominator and change the power to a negative 1 since we brought it up its reciprocal. And then I need to get the same base so I can add my powers. So I have 2 cubed to the 3/6 times 2 squared to the negative 2/6. So this is 2 to the 9/6 times 2 to the negative 4/6. So I've got 2 to the 9/6 minus 4/6. So this is 2 to the 5/6. We can evaluate this, right? So first thing I'm going to do is I'm going to rewrite this in terms of the 6th root of 2 to the 5th. 2 to the 5th means I have 5 2's, right? So that's going to be the 6th root of 32. And that's my answer. Now let's look at 38. 38, we've got the cube root of a squared times the cube root of a to the 4th. So I'm going to rewrite these as rational exponents. So I've got a to the 2/3 times a to the 4/3. My bases are the same, so I can add my exponents. So I've got a to the 2/3 plus 4/3 equals a to the 6/3. 6/3 can be reduced, though, to 2, so we've got a squared. Now let's look at 42. Okay, 42, we've got the expression x to the 3/2 minus 2x to the 5/2 divided by x to the 1/2. So what I'm going to do is I'm going to break this up into 2 separate fractions. So my denominator is going to be the same in each. So I'm going to have x to the 3/2 over x to the 1/2 minus 2x to the 5/2 over x to the 1/2. I'm going to bring up my denominators. So I get x to the 3/2 times x to the negative 1/2 minus 2x to the 5/2 times x to the negative 1/2. My bases are the same, so I can combine. I've got x to the 3/2 minus 1/2 minus 2x to the 5/2 minus 1/2. So then this is x to the 2 over 2 minus 2x to the 4 over 2, which reduces in the powers to x minus 2x squared. All right, 44. Part A for 44 wants us to solve for y, and the equation they give us is y to the negative 1/2 is equal to 6. Now, if I had given you, say for example, 1/4 x is equal to 4, to solve for x you'd multiply by the reciprocal, right? And so you'd get 16. It's exactly what we're going to do, but in the powers this time. So I want to get rid of that negative 1/2, right? Which means that I'm going to multiply. I'm going to multiply both sides. I'm going to take both sides to the negative 2 power. That means now I've multiplied by the reciprocal in that power, so my exponent cancels out on the left, and I'm left with 6 to the negative 2, which is the same thing as 1 over 6 squared, so this is 1 over 36. Let's try another one. For B, we've got the expression 3y to the negative 1/2 this time, and it's still equal to 6. So again, first thing I'm going to do is multiply by the power's reciprocal. We'll take it to the reciprocal power, so that's negative 2. Negative 2. So I get 3y is equal to 1 over 36. And then I'm going to divide everything by 3. 1 over 108. And that's my answer. And lastly, let's look at 48. In 48, we're given the expression 3n minus 1 to the negative 2/3, and that has to be equal to 1/4. So the first thing we're going to do is figure out what the reciprocal of negative 2/3 is. And the reciprocal of negative 2/3 is negative 3/2. So we're going to take both sides to the negative 3/2 power. But when we do this, remember, that means we just put in a square root, right? Because this half right here is a square root. So we have to add in a plus or minus in front on the right. So the power on the left cancels out, and we're left with 3n minus 1 is equal to plus or minus 1/4 to the negative 3/2 power. So what we're going to do now is first flip what's in the parentheses on the right, so we get 4 to the positive 3/2 now. And then the square root of 4 is 2, and this is going to be cubed, so we get plus or minus 8. So 3n minus 1 is equal to plus or minus 8. I'm going to add 1 to both sides, and then divide by 3. So I get 9/3 or negative 7/3, which simplifies to 3 and negative 7/3. And if you check the answers, you'll see that both of those work. And that's the lesson on rational exponents, okay? So the classwork due the 27th for C block and the 28th for F block is at page 458, numbers 1 through 49 odd. I know it seems like a lot, but you'll realize it goes kind of fast once you get the hang of the rational exponents.